guys, I'm here halfway up Mount Yona with your next video lesson. In the last lesson we looked at graphing systems of linear equations. Today we're going to go ahead and take a look at taking that one step further and doing systems of linear inequalities. We're going to be graphing linear inequalities like we did in the last unit, but we're going to be graphing more than one of them on the same coordinate plane and looking where their shaded regions intersect. Alright, let's go ahead and get started.
So our learning target for this lesson is that I can show the solution set of a system of inequalities by graphing on the coordinate plane. So remember back in Unit 2A1 we were graphing inequalities. Our solution set consisted of an entire shaded region instead of just the line. We looked at the graph and we shaded either above the line or below the line to show our possible solutions. For a system of inequalities, where we're going to have more than one inequality on the same coordinate plane, we're going to have to graph both inequalities and look at where those shaded regions intersect. So just to review graphing inequalities first, if we look at our first example, y is less than or equal to 2x plus 3, you see that our graph is already graphed for us, our inequality is already graphed. But just to go over how they got that, remember our y-intercept can be found here. It was 3, so we put a point there. And then our slope was 2. Also can be written as 2 over 1. So we went up 2 and over 1 and put a dot, and up 2 and over 1 and put a dot. Now we also have to look at our symbol and take into account whether we need a solid line or a dashed line. So we look at our symbol is less than or equal to. Since it has that equal to line underneath, we know that we're going to have a solid line here just as is drawn. We also want all the values that are less than that line. So less than, if you recall from your notes from graphing inequalities on the coordinate plane, means we need to shade below the graph. So we are going to shade right here. Alright. Now to be a system, it has to be more than one inequality. So we're going to have to graph another inequality as well. So let's take a look at the second example here. We have y is greater than negative x minus 6. In this case, our y-intercept was negative 6, and our slope was negative 1. We get that because there's no coefficient there, so we know that that is actually a 1 there. So that means we're going to go down 1 and right 1, and down 1 and right 1, and we can keep going with that pattern. Now we need to take a look at the inequality symbol to see whether we need a solid line or a dashed line. If we look at our symbol, it is a greater than sign. So since we do not have that equal to bar underneath it, we're going to need to draw a dashed line as is shown in your notes. Also, since it's a greater than symbol, we need to shade above our inequality. And remember that anything in this blue shaded region is going to be a possible solution. Alright, now, we aren't going to expect you to graph one on each individual coordinate plane. What we're going to expect you to do with systems of inequalities is to graph them together on the same coordinate plane so we can see where they overlap. So if we look at this example over here, this has both of our first example. You can see the line right there, the solid line with the y-intercept of 3 and the slope of 2. And its shaded region over here. Alright, you can also see the one we work second, where it has a y-intercept of negative 6 and a slope of negative 1. That's that dashed line we have here. And remember, we shaded above here. Alright, so now since we've put them both on the same coordinate plane, we can see where our shaded region overlaps. So anything that's in this area that's shaded in both colors is going to be a possible solution set. So we're asked to give some examples of two ordered pairs that are in the solution set. So we're going to go where it is shaded in, and let's just put a dot right there. At 2, 0, that point is going to be in both shaded regions. Also, we could do a point that was on the solid line and in the shaded red region. That would work. Or we can pick any of the ones that are in the shaded red and blue area. Let's just say here. And we would have positive 9, negative 9. Now, we're also asked to identify two ordered pairs that are not in the solution set. That would be any of the areas where it's either not shaded at all, or where we only see one color, or on a dash line. Remember, the dash line means that it's not equal to. So we could do -10, 0 as a possible point, because it's in the area that's not shaded. Or we could do, let's say, -4, 0. That's in the blue shaded region, but it is not where the red region overlaps with the blue. Just like if we pick down here at -1, -9, that would also not be in our solution set because it's where it's just shaded red. Now I know it only asks us for 2, but I just wanted to show that any of those 3 points, whether it's not shaded at all, shaded just in one region, or shaded just in the other, are not solution sets. All our solutions are going to be in the area where the red and the blue overlap over here. Alright, so also we want to take a look at parallel lines. A system of equations with parallel lines has no solution. Parallel lines in a system of inequalities, however, are different. Sometimes we can have solutions even though we have parallel lines. That's unique from our system of equations where we said if they're parallel, since they never cross, we have no solution. But here, since we're looking at the shaded region instead, we can have possible solutions. So let's just take a look at a couple of examples we have outlined here. In this first system of inequalities, we have y is less than x plus 4 and y is greater than x minus 2. Now notice with y is less than x plus 4, that's our line right here, that our inequality is less than. So I know it's kind of hard to see with the different grays shaded, so I'm just going to highlight this in red so we can see where that area was. And then I'm going to do the same thing for the other one in blue. This time we wanted greater than x minus 2. That's this line down here, so we would shade above. And we can see here that we actually are going to have a region where both overlap. So in this case with a parallel line set for inequalities, we actually are going to have solutions. Anything in this region that is here in between these two lines would be considered a solution. Let's look at another situation you might have. Y is greater than 2x plus 4. That is our top line on this equation. And since we are looking at greater than, it is anything up above that line. Alright, I'm just going to shade this blue so you know that's what we're looking at there. On this one, it also wanted greater than, so we're still looking at the area above the second line. So we are going to have this area here where they overlap. So again, we're going to have solutions anywhere in this double shaded area. Notice in this case, instead of being between the lines like it was in our first example, they're going to be above one side of the line. So anything in there is going to be a possible solution. Finally, we'll look at the last example. We have y is greater than -3x plus 5, and that's going to be this line here. And we want greater than, so we are shading above. So we're going to shade out this way. And then we also have y is less than -3x minus 3. So that's this line here. It's less than, so we want to shade below. Now notice in this situation, we actually don't have anywhere where the red and the blue overlap. We have no area where the shaded region overlaps. So this is going to be a case where we are going to have no solutions. So in System of Inequalities, we may have a situation where we shade opposite directions from the lines that do give us no solution. But what's different from the system of equations is that we are going to have some situations where lines are parallel, but they will either overlap in the middle, where they are going opposite directions, or they will go in the shaded region above one of the lines. So we actually do have situations where we do have solutions even though lines are parallel. Alright, make sure you pick up and complete an application for this lesson. We are going to ask that you do all the practice for this lesson and then take the application. And once you're done with those two, go ahead and take a mastery check. As always, let us know if you need any help. We'd be glad to help you out. See you guys in the next video.